Atmospheric rivers are one of the most powerful yet unseen forces that shape our climate in profound ways. These narrow bands of concentrated moisture transport vast amounts of water vapor across the atmosphere. Often described as rivers in the sky, they can stretch for thousands of kilometers. Despite their invisible nature, they play a crucial role in global weather patterns. They are responsible for delivering much-needed rainfall to many regions around the world. However, when atmospheric rivers become too intense, they can cause devastating floods. The west coast of the United States, particularly California, heavily relies on atmospheric rivers for its water supply. Without them, drought conditions would be far more severe. Atmospheric rivers can carry as much water as the Amazon River but in vapor form. They originate over warm ocean waters and move moisture across continents. When this moisture reaches land, it cools and falls as heavy rain or snow. This process significantly impacts agriculture, water reservoirs, and ecosystems. Despite their benefits, atmospheric rivers can also lead to catastrophic damage. Coastal regions are particularly vulnerable to extreme atmospheric river events. Infrastructure, homes, and businesses can be overwhelmed by the sheer volume of rainfall. Scientists have been studying atmospheric rivers to better predict their behavior. Advanced satellite technology has improved our understanding of their patterns. Tracking these weather systems helps authorities prepare for potential flooding. Climate change is expected to intensify atmospheric rivers in the coming years. Warmer oceans contribute to higher moisture content, making these systems stronger. Regions that rely on snowpack for water may face challenges as rain replaces snow. This shift affects water availability for millions of people. Atmospheric rivers also influence global weather phenomena such as El Niño and La Niña. These events can alter the frequency and intensity of atmospheric river occurrences. Understanding their connection to climate systems helps in developing adaptation strategies. Forecasters use computer models to simulate how atmospheric rivers might evolve. This allows for better planning and management of water resources. Agriculture depends on the timely arrival of these moisture-laden air currents. Too little or too much rainfall can devastate crops and impact food security. Flood management systems must be robust enough to handle extreme atmospheric river events. Dams and reservoirs are critical in storing excess water for dry periods. Communities near flood-prone areas need effective warning systems. Insurance industries also factor in atmospheric rivers when assessing risks. Their economic impact can reach billions of dollars in damages and lost productivity. The transportation sector is often disrupted during heavy atmospheric river events. Roadways, railways, and airports can experience closures due to flooding. Public awareness campaigns help people prepare for extreme weather events. Emergency response teams rely on atmospheric river forecasts to mobilize resources. Coastal erosion can be exacerbated by relentless rainfall from these weather systems. Soil stability is another concern, leading to landslides in hilly regions. Forests benefit from the moisture brought by atmospheric rivers. They help maintain biodiversity by replenishing water sources. Wildfires can be reduced in frequency if atmospheric rivers deliver adequate rainfall. However, excess moisture can also encourage the growth of harmful mold and fungi. Historical records show that atmospheric rivers have been shaping Earth's climate for centuries. Ancient civilizations adapted their agricultural practices around their patterns. Modern infrastructure is designed with atmospheric rivers in mind. Flood barriers and drainage systems are crucial in urban planning. Researchers are developing innovative techniques to mitigate atmospheric river damage. Artificial intelligence is being used to analyze atmospheric river patterns. Predictive analytics help in managing water supplies more efficiently. Remote sensing technology provides real-time data on atmospheric river movements. International collaboration is key to understanding their global impact. Countries share data to improve forecasting accuracy and response strategies. Weather anomalies such as droughts and heat waves can be influenced by atmospheric rivers. Their impact is not limited to coastal regions but extends inland as well. The energy sector relies on atmospheric rivers to generate hydroelectric power. When river flow increases due to rainfall, power generation capacity rises. But infrastructure must withstand sudden surges in water levels. The tourism industry can also be affected by atmospheric river-induced weather patterns. Outdoor activities and travel plans can be disrupted by prolonged rainfall. Understanding the seasonal patterns of atmospheric rivers helps industries plan ahead. Some regions experience more frequent and intense events than others. Preparedness measures are crucial to reducing the human impact of extreme weather. Urban areas face unique challenges in managing atmospheric river rainfall. Storm drains and sewage systems must be maintained to prevent overflows. Floodplain mapping helps identify areas at higher risk. Investments in green infrastructure can help absorb excess rainwater. Wetlands and forests act as natural buffers against flooding. Educating the public on atmospheric rivers fosters a climate-resilient society. The science behind atmospheric rivers continues to evolve with new research. Every year, meteorologists gather more data to refine their models. Media outlets play a role in spreading awareness about impending atmospheric river events. Social media platforms help disseminate alerts in real time. Communities can prepare better when they understand the science behind these phenomena. Government agencies allocate resources based on atmospheric river forecasts. Policymakers must consider climate adaptation strategies to mitigate their effects. Scientists warn that failing to prepare for stronger atmospheric rivers could be costly. The unpredictability of atmospheric rivers makes planning a challenge. Water conservation strategies must be in place to balance periods of heavy and low rainfall. Cloud seeding experiments are being explored to manage atmospheric river activity. Monitoring atmospheric rivers helps in predicting hurricane development. Their interactions with other weather systems can have far-reaching consequences. The global water cycle is intricately linked to atmospheric river dynamics. From the Arctic to the tropics, atmospheric rivers influence weather everywhere. Continued investment in climate research will improve resilience to their impacts. If you enjoyed learning about atmospheric rivers, make sure to follow for more insightful content. Staying informed helps us all prepare for a changing climate.